Hello guys, welcome to a little bit more help with a variety of questions to prepare you for your Unit 2 exam. So I've just picked a different kind of set of questions based on some feedback I got from different students and things they would like to see. The picture that you see is our friend the squirrel, who my husband built these little picnic tables when we first were locked down in quarantine. And this squirrel has been around our house ever since. So we named him Sid, but I can get so close to it right now that we've actually found out she's a Sydney. So Sid and I were doing a little photo shoot for school, but I wanted to share with you guys some of the craziness that happens at my house over the weekend. So usually we feed her when we're having a cup of coffee in the morning and having some breakfast, and she was very social this weekend. So there you go. So I might have to actually move the picture of Sid back into the corner. Oh, make it super, super tiny so we have some room to do some math. Okay, guys, here we go. This first question, I would simplify first. So a lot of times when we're working through problems and preparing to do something more with them, simplifying is a really, really nice first step. So I can see right here that I can take the square root of 16, and then I can also simplify this root 12, and I can also pull out an x from the x squared right here. So I'm just going to divide this up so you can actually see what I'm taking the square root of, right? 16 is a perfect square times x, so that'll come out. And then on the bottom, I'm going to divide 12 into 4 times 3. And I'm going to divide x cubed into x squared times x. So when I simplify, on the top, I'm going to have 3 times 4 on the outside of my radical. And down here, I'm still going to have my 5. Square root of 4 is 2. Square root of x squared is x. And I'm going to be left with a 3x underneath my square root. So we can even simplify a little bit further by reducing our fraction before we go through this process of rationalizing the denominator. So I'm going to do that real quick. I'm going to change this into a 6 over 5. So 6/5 instead of 10/12 x, and then root 3x. So after I get it to this point, that's when I think it'd be a good idea to go ahead and rationalize your denominator. So I'm going to multiply by root 3x over root 3x. I'm going to zoom down to this next line right here. So as a result here, I'm going to get 6 and then 3x squared in my numerator. And I'm going to get, it looks like 5x times root 3x times itself there is just going to be 3x. So we got rid of that square root. We have an x squared here, so that's going to come out. We're still going to have a 3x left. In the denominator, it looks like I have what? 15x squared. How did I get that other x in there? So we're set to go here, and we will have x squared in the denominator. This still can simplify. There's so much simplifying that's going on here. So 6 and 15 are both divisible by 3, and I'm going to cancel one of my x's top to bottom. So it looks like I'm going to have 2 root 3x over, and then 15 is divisible by 3. And I'm just going to have an x left there. Okay, so remember what happened from this step right here to this step is that 6/15 became 2/5, and the x over x squared, one of the x's canceled in the top with one of the x's in the bottom, to arrive at our final answer. There we go. So remember, simplifying is a great way to start things off. Okay, guys, let's keep rolling. Okay, we'll use as much of this video as we can, and then if we need to make a second one, we will do that. All right, this crazy problem right here. In fact, these two crazy problems right here, I had a couple of different people ask me about doing some more examples with rational exponents. I guess the first thing I would do with this problem is to get rid of the 2. So I'm going to actually just on both sides here, I'm going to multiply by 1/2. And so what I'm left with on 2 divided by 2 is just going to be 1. So I'm left with, and I'm going to write it a little bigger now so you can see it, is equal to 1 over, what does that turn out to be, like 512? Okay. Now here's the part where we're going to get rid of this fractional exponent. So I'm going to raise this side, and I'm going to raise this side to a negative 2/3 and a negative 2/3. What that does for this fraction, or what this does for this left side of my equation, is now I have an n to the first power. So that's just going to be n. Over here, because that is a negative exponent that's being applied to both the 1 and the 512, it's going to actually bring your 512, it's going to bring it up into the numerator. So it actually becomes positive. So thinking about what we do with those negative exponents, and of course 1 to the 2/3 is just 1, so we don't even really have to write that part. Let's just get rid of that so we don't have to mess with it. And then this becomes our question, right? Can I evaluate n equals 512 raised to the 2/3? That's the cube root, and we've been practicing these, of 512 raised to the second power. And it turns out the cube root of 512 is 8. And then 8 squared gives us our final answer of n is equal to 64. Okay? So that's how those roll out. This next one is super intense because it has negative exponents. It has a situation where you are having to find common denominators with fractions and things like that. And in fact, before we even get going on this, I am afraid I'm going to need more room, so I'm going to move this down a little bit. There we go. Okay. Whew. Hopefully that'll give us enough room for this crazy problem. All right. So I think I appreciate all the questions that you guys were asking around this chapter. I think, again, I would start with simplifying. Anything that you can simplify. That might mean, for example, getting rid of these parentheses that are right here. It might mean changing our negative exponents to a positive exponent. So I'm going to do those 2 things in this first step. I'm going to keep my x to the 1/3. I'm going to keep my y to the 3/2. This x to the negative 1, I'm going to bring it up into the numerator as x to a positive 1. Then in the bottom, I have a y to the first power, just right there. And then the 7/4 is going to get applied to both of these. So that means I have a y, whoops, doesn't like me pressing things. No, do not ask me again. Okay, well, just a minute. Time? Okay, we're back. I got rid of it. So the y to the 7/4 in this space, and then when you have a power to a power, remember you're going to multiply your exponents. So I think 1 times 7, 2 times 4, that gives us 7/8. Okay. So here's what I'm going to do. I'm going to combine my x's in the top of my fraction, and I'm going to have to rewrite 1 as 3/3 here so I can combine these two. See that? And I'm going to rewrite my y to the first here as 4/4 so I can combine these two by adding my exponents. So let's keep crunching along here. What does it look like? X to the 4/3, right? And y to the 3/2 in the numerator. In the denominator, it looks like I'm going to have x to the 7/8. I'm just going to line those up. And y to the, what is that going to be? 11/4. Okay, perfect. Now here's where things get crazy, because I really need to subtract. I need to subtract my exponents here going down with my x's, my like bases. I need to subtract my exponents here. So the two problems I really need to figure out are 4/3 minus 7/8, and please don't forget you have to have a common denominator for that. If you need to pause on your own, you know, get your common denominator of 24 here, right? Would you have to multiply 3 times to get to 24? 8, so 4 times 8, all right? Remembering how to get common denominators takes a little extra work. Times 3, so we have 21. So our subtraction is going to yield 11/24 for that particular problem. And then for the 3/2 minus, what's it going to be, 11/4, we probably need 8 as our common denominator here. So 12 minus, and then 8, 12 minus 22. So it went with a negative 10/8, which actually is the same as a negative 5/4. Okay, so those will yield interesting results once we get them with our bases. So here we go. Remember, these were subtracting our exponents. So we have x raised to the 11/24. And because this is a negative exponent right here, we're going to say y to the 5/4. It kicks it into the bottom of your fraction. And then we have this weird little directive where sometimes you can't have a fractional exponent in the bottom of your work here. So I'm going to multiply by y to the 3/8 over y to the 3/8. And again, this is a strategy that we're using, and I don't even know if you'll see this strategy on your exam. You may, but you may not. But we're using the strategy to get a response in the bottom of our fraction that actually is going to be, oops, 3/4, sorry. 3/4. Goodness sakes, why didn't somebody catch me? You guys need to give me some feedback there. Shout louder. All right, so what happens here is then we get our 8/4, and because 8 is divisible by 4, now in the bottom of our fraction for this problem we have a y squared, and that's what we're shooting for. In the top we still have x to the 11/24, that cannot be reduced, y to the 3/4, and that holds as we come across our numerator. All right, guys. Well, I'm gonna take a little break right here. All right. I'm gonna kick off our next video in this space. All right, so video part 2 will be coming at you in a click of a button. All right, just go to that second link and we'll do a few more problems together. All right, see you soon.